I thought I'd make a quick video on NIC teaming in Windows Server. So you can do this in Server 2012, 2016, 2019, and more specifically, NIC teaming in switch independent mode. So the reason I thought I would make this video is because I thought it was kind of confusing at first as to how this worked at the data link layer. So at layer 2, where we're dealing with MAC addresses, I thought that if the team is assigned a MAC address and the server is connected to 2 different switches, how do the switches not get confused? So I knew there was some magic behind it, and of course that's the case. I wouldn't really call it magic, but the way they designed this makes sense. And after not being able to find much information on the internet, that's why I decided to lab it out and figure it out for myself. So we just have a real simple topology here where we have the server connected to 2 different switches, and these switches connected to an access switch, and then the access or a PC connected to that access switch. It's a layer 2 topology, so of course spanning tree protocol is involved. Yuck. I am not a big fan of spanning tree. I don't think anybody watching this really is either. But anyways, with that being said, this is the spanning tree root bridge, so I assigned this the lowest priority of 4096, and then this would be the backup root bridge with the next lowest priority. So that would make this a designated port, root port, and since this is a tie right here, then since this has the next lowest priority, this would have a higher priority. That would make this port blocking. So I know this isn't a spanning tree lesson, and actually I don't think spanning tree really plays a major role in what it is that I'm trying to explain in this video anyway. So let's move along. So with that being said, let me show you the physical equipment where I labbed this up. So we have, so this would be switch 1, switch 2, access switch. These would be the 2 connections that are going to the server that we have the NIC team configured on. And what I'm using for that is, it's an old Dell PowerEdge 1950 that I have in this rack for weekly backups and whatnot. And then connected to the access switch, we have that PC as shown right here. And the PC is just patched into my patch panel, which then goes over to the laptop I have sitting on my desk. So this should be very short, but to show you how this works and how the switches do not become confused with the MAC addresses, let's take a look at the server. And I have the network connection details up that show the MAC address of the NIC team. Just pay attention to the fact that it ends in E1F0. And let me start a file transfer over here. Since, like I mentioned, this is my backup server, so I have quite a bit of stuff already on here. So I'll get this copying. So that way we have some traffic, and the MAC address tables on the switches will be populated if they weren't already. Okay, so now let's go over here and let's take a look at switch 1. So if we do a show MAC address table, you have to excuse me too, because I'm trying to type with one hand while I'm looking at the camera. Show MAC address table. And let's look specifically at Gigabit Ethernet 1/1, where one of the NICs for this NIC team is plugged in. We'll see that the MAC address ends in E1F0. Same MAC address for the NIC team on the server. Now, let's take a look at switch 2. We'll also do a show MAC address table. We'll be looking at Gigabit Ethernet 0/1, where the other NIC is connected to the server in the NIC team, we'll notice that the MAC address is different. And that's basically how it works right there. Is that inbound communication. So basically, let me back up for a second. So when you configure NIC teaming on the server in switch independent mode, it actually picks, even though the outbound traffic is load balanced, it actually picks one of the NICs as primary, even if you don't select one as active, one as standby. So with that being said, inbound traffic is going to be sent to one of the network interfaces on the server. So when the host that you're using to access that server ARPs for the MAC address for that server's IP, it's actually going to send the MAC address. It's going to say, this is my MAC address right here for NIC Team 1. However, that primary physical NIC is going to be the one, there's only one NIC, that primary NIC, that's going to respond to requests destined for that MAC address. So when the server starts sending outbound traffic, say you're copying a file or something like that, like I was just doing over there, both NICs are going to send traffic. It's going to load balance the traffic out of both of the network interfaces. But as you can see on here, like I showed you this, the MAC address table on switch 1 and switch 2, one of the NICs, the primary NIC, which I happen to have connected to switch 1, which is also that, like I said, the spanning tree root bridge in this example, is going to send using the source MAC address of the NIC team. The second NIC sending traffic is going to send using the source MAC address that is its actual burned in MAC address. So that's pretty much it. It's as simple as that. Inbound traffic, one NIC, the primary NIC, takes over for that the MAC address for the NIC team, and when outbound traffic is being sent from the server, then they both send information, and that primary NIC, that one NIC uses the MAC address of the team, the other one uses its own MAC address. And of course, in the event of a failure, so let me pull the cable for switch 2. I'm sorry, not switch 2. Let me pull the cable for the primary switch. So in the event of a failover, pretty simple. If we look at switch 2, now the remaining NIC is going to take over. So as we saw right here, it was ending in E1EE. If we do a show MAC address table again, now that we unplugged the primary NIC, we have E1F0. Alright, so if you have any questions, feel free to leave a comment in the comment section below, or send me an email to rob@rmtechcentral.com. I'd be more than happy to help as much as I'm able to. And if you like this video, please give it a thumbs up, and also consider subscribing to my channel if you're not subscribed already. I would very much appreciate it. Alright, I will see you in the next video. Thanks for watching.